Assalamualaikum and hello everyone. I'm Nurliana binti Muhammad Tani from OUM Kuching Learning Center. I'm currently pursuing Bachelor of Occupational Safety and Health Management with honor under the Faculty of Technology and Applied Sciences. And today I'll be presenting on the topic of green chemistry principles for pollution prevention. Okay, first of all, what is green chemistry? Green chemistry is the design of chemical products and processes that minimize or eliminate the use of generation of hazardous substances. It focuses on sustainability, protecting human health and the environment while maintaining efficiency and innovation. Now, let us dive into the 12 principles of green chemistry. First, prevention. It's better to avoid waste than to clean it up later. Many factories now recover and reuse solvents instead of dumping them. It saves money and reduces pollution. Second, atom economy. This means using every atom efficiently so nothing goes to waste. In pharmaceutical industries, modern syntheses now use up to 90% of raw material. Next, we've got less hazardous synthesis. It's about designing chemical reactions that don't involve dangerous substances. For example, using carbon dioxide as a solvent instead of toxic chlorine compounds, much safer for workers and the environment. Fourth, design safer chemicals. Make products that work well but don't harm living things, like biodegradable detergents that clean effectively but don't destroy marine life. Fifth, safer solvents and auxiliaries. This one's all about choosing safer helpers in the lab. For instance, using water or ethanol instead of benzene, which is toxic and flammable. Next, energy efficiency. Conducting reactions at lower temperatures saves energy and cost. Catalysts are often used so reactions can happen faster even at room temperature. Seventh, use of renewable feedstocks. Instead of relying on fossil fuels, industries can use plant-based materials. For example, producing bioethanol from sugarcane. Renewable, sustainable, and locally sourced. Eighth, reduce derivatives. Basically, don't do unnecessary steps like adding or removing groups that just make the process longer and wasteful. Simpler reactions mean fewer chemicals handled, less risk for everyone involved. Ninth, catalysis. Catalysts help reactions go faster, cleaner, and with less waste. Enzymes, for example, are used in textile industries to replace harsh chemical treatments. Tenth, design for degradation. Products should break down safely after use, not stick around forever. Biodegradable plastics are a great example. Number 11. Real-time analysis. It means monitoring processes while they happen to catch errors early and prevent waste. Industrial sensors now help detect problems before they cause chemical spills. And finally, inherently safer chemistry. This principle is all about designing systems that minimize the chance of accidents in the first place. For instance, using non-flammable refrigerants instead of dangerous CFCs, protecting both workers and the ozone layer. Now, let's talk about how green chemistry connects to occupational safety and health. This is where things get real because greener chemistry doesn't just protect the planet, it protects people. By replacing or reducing toxic, flammable, or highly reactive substances, we cut down the biggest workplace hazards right at the source. Fewer dangerous chemicals mean fewer accidents, fewer burns, and healthier worker overall. Here are some of the key safety benefits of applying green chemistry in industries. First, less exposure to carcinogenic and corrosive substances, lower risk of fire and explosion thanks to safer solvent, reduced chemical waste, which means fewer disposal accidents, and better indoor air quality in labs and factories, making every shift safer. And in Malaysia, these practices align perfectly with our Occupational Safety and Health Act and the Environmental Quality Act. Let's look into this case study. Petronas has applied catalytic processes to reduce carbon dioxide emissions and save energy, achieving significant progress towards sustainable petrochemical production. Next, practical tips and industry application. In industrial settings, chemical audits are conducted to identify hazardous substances so they can be replaced with safer alternatives. The ISO 14001 environmental management system is implemented to monitor and minimize environmental impacts. Renewable energy sources such as solar and bio-based fuels are increasingly being invested in for cleaner production. Life cycle assessment or LCA is applied to evaluate a product's sustainability from the use of raw materials up to its disposal stage. In many organizations, green innovation teams are established to identify and improve waste reduction strategies. In laboratories and educational institutions, macro-scale experiments are practiced to reduce waste generation. Lab glassware and containers are recycled whenever safety allows. Greener reagents such as ethanol are used in place of harmful ones like acetone. Students are also encouraged to propose green chemistry projects as part of their coursework and final year research. Did you know the term green chemistry was first introduced in the 1990s by chemists Paul Anastas and John Warner, and they literally wrote the textbook on it? What's the goal of green chemistry? It is to create safer, cleaner, and less wasteful processes. And that's all from me. Thank you for watching.